GATE 2016 Civil Engineering Set 1 Question 35. A reinforced concrete beam with width of 250 mm and effective depth of 400 mm is reinforced with Fe 415 steel. As per the provisions of IS 456-2000, the minimum and maximum amount of tensile reinforcement expressed in millimeter square needs to be found. The relevant NPTEL reference has been mentioned. When we talk about reinforcement of tensile nature in a beam, we should refer to the clause 26.5.1.1 of IS 456-2000. As per this clause, the minimum steel in a beam is given by 0.85 times the width into effective depth divided by the strength of steel. Similar manner, the maximum steel requirement is given as 4% of the area, that is B times capital D. Here D is the depth and B is the width. In this question we have been given the width as 250 mm, effective depth has been given as 400 mm, and Fy is given in the problem as 415 Newton per mm square. So using these three values to find the minimum amount of tensile reinforcement, which is 0.85 into BD over Fy. Substituting the values, we would get 0.85 into 250 into 400 divided by 415. This would give out the value to be 204.82 millimeter square. This can be rounded off to 205 millimeter square. Similarly, we can find the maximum tensile reinforcement, that is 4% of the area of the beam, 0.04 times B into D. Here we don't know D, so we can take D as close to small d itself. So 0.04 into width, that is 250, and depth we are approximating it as 400. This would give out the value as 4000 millimeter square, which is the maximum tensile reinforcement. So the minimum and maximum amount of tensile reinforcement for the section are 205 and 4000 millimeter square, which is option B. The relevant NPTEL reference has been mentioned.